Hi, in this video, we're going to continue to talk about functions, specifically how information flow into and out of a function. If you think about this, I actually defined a variable inside a function, okay? And this is what's called a local variable, a variable that is local to the function itself. What that means is that this variable is only visible inside this function. So if you want to print that variable outside of the function, it's not going to see it. Okay, and when you run it, it's again, what in the world is message? Okay, so this is important to remember. Okay, when a variable name is appear on the left-hand side of an assignment operator inside a function, it creates a local variable, and that local variable is only visible inside the function. So when you want to use it outside the function, it doesn't see it. And we another way to kind of see it, you're going to see this thing called a variable scope quite a bit. The scope of this variable message is local, it's inside the function. Okay. So then the question that the next question may be that, okay, now that we have this greeting message, it's always hello world, can we print a different greeting message? Well, okay, so sure, can we change the message to something else when we call greetings, right? I mean, we can obviously just change it here, but that means if we want to call greetings multiple times, then how do we print a different message every time, right? We cannot, the way it is written right now. So one way to actually achieve that is, okay, local variable is visible inside but not outside. Then, but on the other hand, there's this thing called the global variables that are created outside the function, and they are actually visible inside the function. So as a matter of fact, all the variables that we have created so far in the last 3 weeks, or however many weeks, they are all global variables, and they are visible everywhere inside your program. I'm going to have to underline everywhere. That's important. Okay, these global variables, they're visible everywhere. So what that means is, if I take message and I put it outside, say it's not complaining because the function can see the global variable. And when I run this, well, it sees hello world, right? What that means is that I can change message to something else. I'll change it to something else. Good morning. And if I call greetings again, well, hopefully it will print out a different message now. So there, right? The hello world is the first invocation of greetings. That's when message is hello world, right? So it prints out hello world, and I change it to good morning, and the second invocation of greetings prints out good morning. Okay, I hope that kind of makes sense. Now, one thing to note is that, well, same thing kind of about, you know, when can we invoke a function? Well, it must be defined before we can invoke it. So the same thing for variables, we have to kind of define it before we invoke a function. So let's say if we put this afterwards, after we invoke the function, it's not going to work, right? Right, it's not going to work, right? Because when the control comes here, sorry, yeah, when the Python interpreter comes to greetings, it tries to call the function, and then when it comes to here, it's like, what message are you talking about? I have not seen a message yet. Okay, so that's why it's not happy. Now, technically, you can just put it here. It will work. It might be confusing to some of you, even because message is still defined after you define the function. Um, so that's okay. I don't want to get bogged down with that detail. If this makes you feel more comfortable, you know, this is what you should do. Okay, but um, here's what. Okay, so okay. Let me finish this slide first. So basically, as we already just seen, we can change the message and the greeting will see the new message and print a different message each time, right? However, using a global to change the behavior of a function is not good. In fact, it's very bad. Okay, very bad. And this is something that you should not do. Okay, and I'll try to give you an example to hopefully illustrate the point why this is bad practice. So imagine a restaurant, okay, and in order for a customer, maybe you, come in and order the dish, there's a single piece of paper. Okay, so a global variable is like that single piece of paper. There's one single piece of paper for the entire restaurant that when a customer wants to order something, he must write the name of that dish on that piece of paper. Then the kitchen will look at that piece of paper and decide what to cook. Then the kitchen is kind of, when the kitchen performs an action, that's kind of like, invoking the cook function. So inside the cook function, it looks at that piece of paper, figure out what to cook, and then cook it. Okay, now imagine that restaurant has 20 or maybe 100 for a very successful restaurant. 100 customers, each of them is trying to order multiple dishes using that single piece of paper. Okay, I don't know if you can imagine that. The way I see it is, it's gonna be a total mess, right? It's gonna be total chaos, and um, and I don't know how long it's gonna take for all the customers to go through all the ordering because there's only one piece of paper, and each time it only contains the name of one dish. So that's gonna be very slow, and and who knows? Maybe customer A wrote down the name of a dish before before the kitchen has a chance to look at it. Another customer come in and erase the name of that dish and put a new dish in. So there might be errors, right? That the kitchen would skip the dish for a particular customer or lots of customers. In any case, I hope you can see that this is a big problem. Okay, and that's kind of what the global variables are, because there's only a single copy of them out there, or I mean, it can be multiple global variables, but it doesn't matter. The key is there's a single variable that can be used over and over and in a very chaotic, inefficient manner. Okay, so fortunately, I don't think there's ever a restaurant that operates like that, right? So in order to order dishes, the customer or a waitress, they write down a list of dishes on separate pieces of paper, right? And those separate pieces of paper are passed to the kitchen. So the good thing is there's an analogous way to pass pieces of information to a function in programming. Okay, we don't have to use global variables. And to do that, we use what's called parameters. Okay, so a function can take a parameter. Here I'm going to call it message. Then when we want to call, when we want to call a function with a parameter, we are going to give it the value for that parameter. So I'm going to say hello world here, and I can just completely get rid of this. And I'm going to take this out for now. Okay. So I did not change much. I just put an additional parameter in the definition of a function. And when I call the function, I give a value to that parameter. So this value is called an argument. So yeah, parameter is in the function definition. Argument is in the function invocation. Okay, and hopefully, we'll run it. It does exactly the same thing. And then one way to think about parameter is that they are parameter, the message, is really just like local variables. And the value of this local variable, this parameter, is set by the caller. So in this case, the value for message is hello world. All right. And then yet another way that may be helpful for you to think about is parameters are kind of like inputs to a function, right? So we have a function that's called greetings. Greetings takes a message as an input and it prints out that message, whatever it is. Okay, so now let's actually write something that is maybe does a little more than just printing a greeting message. Let's actually write a function that calculates the area of a circle. So I'm going to call it area of circle. Now, area of a circle is a function of its radius, if you remember from your math days. So basically the area is just it's a pi. I can type 3.1415 blah blah blah, but I'm going to use math.pi. It's pi r square. Okay, I'm going to import math. Okay, so I imported math, and that's it. And when I'm done calculating or computing, I say area is that. Okay, and in order to call this, I'm going to say area, and I'm going to say radius is 10. And there's that, and the area is 10 squares, 100 multiplied by 3.1415 blah blah blah, that's 314, etc. Okay, so that's what that is. And yes, I can actually invoke it multiple times now. This is why we write functions, right? We can very easily calculate the area of a circle. Okay, I can even say area of a circle of radius blah is that. So that will make it more clear which, radius corresponds to which area. So that's that. Now, I want you to try to write a couple functions of your own. So, first function is, let's define a square function. So all it does is square a number, right? Should be fairly straightforward. And the next thing is, let's try to write a function that adds three numbers together and then print out the sum. Again, should be very straightforward. So pause the video and give that a try. All right, assuming that you've done that, let's move on to the next topic. But as a motivation, let's think a little bit about there are actually differences between these built-in functions, print versus length and range, what they do, and specifically what they actually get back to us. So think a bit about what the differences are between these built-in functions. What I'm trying to get at is print puts something on the screen, but it doesn't really give any information back. Whereas length, it gives us the length of a list, the number of items in the list or the number of characters in a string, right? And the range gives us a sequence of number. In both cases, we take the information returned by these built-in functions and we do more with them. Right? Imagine if these functions only print the information on the screen, but not returning the numbers or a sequence of numbers, well, they're not very useful for us. So as kind of a small tangent, printing is really often a very poor way of returning information because printing doesn't return anything. Now, so we want functions to be able to return things, information, so that we can further use them. And in the example of actually area of circle, instead of printing things, printing the area out, we more often than not, we wanted to return that information. So we just, to return something from a function, you literally use the keyword return. Okay, and you can return, in this case, a number, an area. Now, when you run this, okay, there's nothing. What happened here is that we return a number, but we didn't do anything with the number, right? So this is kind of equivalent to saying, I put a number here, 45. What does it do? Well, it doesn't do anything, right? So what we want to do then in this case is we want to print that information. Let's say, right? We can do other things. And again, you really should not do useful work in a print statement, but I'm doing this as a demonstration, for demonstration. So here, we return things. We print out what's returned from the function. Okay. Before I move on to the next thing, just want to say, kind of what the return value of a function can be thought of as an output, if that helps you. So as we just saw, the parameter is kind of like an input, not always an input, but usually an input, right? We feed the radius into this function that calculates the area of the circle, and this function gives us back the area of a circle as an output. Now, how does this work step by step? Okay, so let's go through this piece of code. So again, we have a definition of a function area of a circle. Now we come here, in this case, we assign this piece of code says area equal to area of a circle, that is 10, right? So the Python interpreter sees this is a function invocation, so it transfers the control to that function and assign the value 10 as an argument to the parameter, so radius becomes 10, and then it will go to the first line of this function. It does the calculation. Area, because this is 10 squared is 100 multiplied by pi, so the area is this 314 dot blah 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 number, and then it returns this number. to this line that the function is invoked from. Okay, that's why we keep an arrow here. This is where we call that function. So this number area, 314, is the return value of this function. So you can kind of think of it as this value literally kind of replace this function call. So we are assigning 314, the value returned by the function call, to the variable area. So area is now 314, and we print it out. It's worth repeating how the information, in this case, the value of the area, flows between the two functions. The one that we wrote, area of a circle, which returns a number, and that is assigned to a variable called area, and that variable area is then passed onto the next function call, which is print in this case, and print is the one that puts the value of area on the screen. So you might want to ask then, what happens if when we return the value from an area of a circle, the function call, if we don't assign it to a variable named area? We assign it instead to a variable with a different name, say A, even though again A is not a good name, but just for demonstration purpose, it's a different name from the area that the variable inside the function. Would this still work? Well, the answer is yes, it would work. So because the area, it was just a local variable. However, it is returned to where the function is called, and so the value of area is now then assigned to a variable named A, and A has the value of whatever this function returns, and that is passed on to the print function. So that would work. What about a slightly different case? If we just calculate, if we just call the function, but we don't assign what it returns to a variable, but we still try to print out the variable area, would that work? Well, this won't work because area is again a local variable. It is only visible inside area of circle, the function. But this print statement, when it's referring to the area variable, it cannot see the local variable that is inside area of circle function. So when you run this will give us an error because area is not visible or is not defined in this scope. All right, what else can you do with the value returned by a function? Well, you can use in any expressions or statement where a value is expected. So for example, I can actually say something like areas of two circles. And I'm going to say area of a circle of 10, maybe plus area of a circle, I don't know, 100, something like that. And then I can print it out. And that's really that. If I take this out, right? Basically, as I said, you can the return value can be fed into any other expressions or statements. Common mistakes. Not sure if this is really a common mistake, but I've seen people do that. The return value of a function you can use anywhere where a right-hand side value is expected, but you cannot put it on the left-hand side of an assignment operation. If you think about this, it makes absolutely no sense whatsoever that if you try to do, area of a circle say 10, and then you assign another value to it. This, yeah, you basically, Python is telling you cannot assign value to a function call. This just makes absolutely zero sense. Okay. And then, yes, function can call other functions. This is something very useful, right? So, for example, what I had here was, where is that? Okay, there. That I defined another function called show off. It's just showing off how, I can calculate the area of a circle with a big radius, right? And all that is I have a big radius. Let's make it even bigger. And then I call the function to calculate the area, and then I print out the result. And then here I call show off, right? So there, it's the area of a pretty big circle. So yeah, and so the way, as you can see here, we call a function that we define ourselves, and then inside that function we call another function that we defined ourselves. And if you want to step through the code to see how it works, this is pretty similar to what we had before, but once we have here, come on, that piece of thing. Okay, go away. So show off, it comes to the first line of show off first, and then it comes to a second line. The second line calls another function, so the control pass to yet that function again up here, right? And then when that function is done, it returns to this line, and then when that line is done, well, I mean, yeah, and then when that's done, it moves on to the next statement, which actually does the printing. And then now this function is finished, it would go back to where that function is called, and that's there, and then it continues on from there. Okay. All right, so I think again it will be your turn to kind of practice how to return results. So what I would like you to do is convert the square that you just wrote to return the result rather than printing it, and then convert add the three numbers to return the result instead of printing it. And then finally, I would like you to write a function that that's kind of like add, but before you add the numbers, you should square them using the square function that you write. So basically this add square is you're going to square A, B, and C, and then add the sum together. So go ahead and give this a try on your own, and we will have a lot more to say about functions in the next video.